we do a small part of functions today and end functions with this. Okay, so first thing we will do is types of functions, new types of functions. So types, there are mainly three. I'll write it like this. One second. One will be injective, then is surjective, and then bijective. You'll think these names are so confusing. Simpler names are there. First, let's talk about injective. What is injective functions? Injective functions are also called one-to-one functions. Understand? One-to-one function. Okay. Meaning it means that if there is some f of x to y, okay, for one second, for all x1 x2 belonging to x, f of x1 is equal, if f of x1 is equal to f of x2, that implies x1 is equal to x2. Otherwise this function is called what? Many to one. Otherwise this function is known as. What does this mean? Let's say we have the natural number set and this is the 2 into natural number set. Okay, means 2, 4, 6, 8 and so on, and this is 1, this is 2, this is 3 and so on. So 1 gets only mapped to 1, 2 gets only mapped to 4, 3 gets only mapped to 3, 6, sorry, it's 1 gets mapped to only 1. Understand? 1 to 1, this is what means. Otherwise if the function would have been like this, say -2 2, I'm not writing else, this is x and this is, let's say, x square, then this would be many to 1. See, it is 2 to 1, meaning actually there is nothing but many to 1 value. Understand? One value is going from one value here, and here many values are going from one value here. This is many to one function I told, and inject one to one function I told. So one to one function is called injective function. Now what is surjective functions? This means onto functions. This actually means if there is a function in this, obviously the whole thing has to be mapped, and if both are fully mapped, then we say that to be an onto function. For example, if I give -2 2 3 and I give you here 4 and 9, so as you can see, if this is x to x square, okay, you will say everything here is mapped, everything here is mapped. So such a function is now known as what? Onto functions. Onto functions if both sides are mapped. Okay, now what is a bijective function? You would say bijective function is nothing but one to one onto. What does it mean? Both injective and surjective. For example, 2 3 4, writing 2 3 4 and 6 for example, and here let's say 36 16 4 9. So as you can see, my charge has gone out. I have to put it on charge. Yeah, 2 gets mapped to 4, 3 gets mapped to 9, 4 gets mapped to 16, 16 to, why 60, this is 6, okay, this is 6 gets mapped to 36. As you can see, only 1 to 1 and all things are mapped here. Or you can actually smartly say onto is nothing but when domain, sorry, where was I? Yes, this one, codomain codomain is equal to the range. I told you earlier that the range is the subset of codomain, but here codomain is the range, or range is the codomain, whatever you say. Now let's do one sum. The sum says that prove f r to r f of x equal to 2x is a bijective function. This is the question. Okay, this is the question. So f is 1 to 1, how you would say? That is why 1 to 1, I told you what, f of x1, if f of x1 equal to f of x2, that means what, 2 of x1 equal to 2 of x2, then x1 equal to x2. So this is 1 to 1, this is 1 to 1. I'm writing here 1 to 1. Okay, 1 to 1 answer. Now we have to show it on to. Now let's say that f of y2, f of y by 2 is nothing but f of y. Okay, now y y belongs to r, we know, and this thing will also belong to r. So I can say that all the forms of f equal to y by 2, there are infinite many y by 2s and will be mapped with y belonging to r. So I can say this function is onto. So in such case, this is a bijective function. Next, one thing I am going to say this you can know as a fact here. If I say f o g x, okay, what does this mean? This is nothing but applying the function f on the g of x. Understand this clearly? This is just a fact tidbit you want to know. Maybe sometime it may be required. So I think with this, we'll do one more sum. Should I? I told you this. Now I think no more sum is required. This much is okay. So I think we'll end it here. So functions is also done. Functions done. Next day we start with limits. So let's end it here.